Question 14. This question isn't hiding what type of question it is. Weakens means we're dealing with a weakened question. For a weakened question, we have to attack the argument's assumptions. That's how we weaken an argument. Before we can find the assumptions, we need to understand the argument, which means understanding the conclusion and the evidence. So let's look for those. A nice therefore marks the conclusion of this argument. Therefore, what destroys the enzyme is not heat, but microwaves, which generate heat. So the evidence we're given is basically some kind of experiment. They took a cup of raw milk and heated it in a microwave to 50 degrees Celsius and measured and found that it contains half of the initial concentration of some enzyme named lysosome. In my head, whenever I get a fancy science word, that just becomes L. So some particular enzyme L. If, on the other hand, the milk reaches that temperature through exposure to a conventional heat source, so I don't know, like a stove or something, it will contain nearly all of its initial concentration of the enzyme. So basically we have two different little experiments balanced on that however. Microwave the milk to 50 degrees Celsius, it destroys half of its L. Heating it to 50 degrees Celsius on a stove, it doesn't lose any of its L. It contains nearly all of that enzyme. So what destroys the L is not heat the microwave produces, it's just the microwaves themselves. So this is a causal argument. Anytime you're making an argument that something caused something else, that requires a couple of assumptions, but the most important of them is that there's no alternate cause. So for this argument, the assumption is that there's no other way that the heat from the microwaves could be destroying that enzyme. They've eliminated one possible way, basically the final temperature. So the 50 part's the same on the stove and in the microwave, so it's not the 50 degrees Celsius end temperature that's destroying the enzyme. So since they've eliminated the final temperature, they've eliminated heat entirely. Our assumption is, well, there's no other way that heat could destroy the enzyme in the microwave. So on to the answers. The correct answer is going to attack that assumption. It's going to make it less likely that there's no other way. The easiest way to do that would be to provide another way. Answer choice A, heating raw milk in a microwave oven to a temperature of 100 degrees Celsius destroys nearly all of the L. Well, what happens when you heat it to 100 degrees doesn't really matter. We're trying to figure out, when you heat it to 50 degrees, is it the microwaves or is it the heat that's destroying the enzyme? What happens at 100 degrees is outside the scope of this argument. Answer choice B, enzymes in raw milk that are destroyed through excessive heating can be replaced by adding enzymes that have been extracted from other sources. So, in other words, when you ruin your milk, you could fix it using some chemical process. Well, what happens to it after it's ruined isn't going to help us prove what ruined it, what destroyed those enzymes. So B is also not our answer. Answer choice C, a liquid exposed to a conventional heat source of exactly 50 degrees Celsius will reach that temperature more slowly than it would if it were exposed to a conventional heat source hotter than 50 degrees. Well, I have no clue in the argument exactly what kind of heat source they used. They said it was a heat source of 50 degrees Celsius, so I guess that's exactly 50 degrees Celsius. What happens with hotter heat sources doesn't really matter. Things hotter than 50, just like A, not our answer. D says milk that's been heated in a microwave oven doesn't taste noticeably different from milk that's been briefly heated by exposure to a conventional heat source. I'd say, okay, well, apparently enzyme L doesn't affect the taste. Whether you can taste it there doesn't help you figure out where it came from or what destroyed it. So D is not our answer, which means that E has to be our answer. It's the only one left. Let's see why. Answer choice E says, heating a liquid by microwaves creates small zones within it that are much hotter than the overall temperature that the liquid will ultimately reach. when you heat in the microwave, the heat itself is different than the heat on the stove. Even though they reach the same final temperature, the way they get there is different in a way that suggests that maybe it is the heat in the microwave that's destroying the enzyme. Parts of the milk is getting really, really hot. Maybe that's what's causing the enzyme to be destroyed. Since answer choice E provides us with an alternate cause, it weakens the overall argument.